Hi folks, today we're going to start chapter 4 in our books, which is dealing with quadratic equations and the graphs of those quadratic equations known as parabolas. Now, our first order of business is to find this axis of symmetry, which you will see as these red lines that are going through the middle of our graphs. Our graphs are called parabolas, and they're very much like our absolute value functions that we got done working with earlier, where it either opens up or down depending on what a is. Okay, a is always this number in front of x squared, and if a is positive, the graph will open up. And if a is negative, the graph will open down. A, as I said, is always in front of x squared. B is always in front of x, and C is always this constant number. Now, all three of those numbers are going to come into play here in just a little bit as we go through this. Now, some other things that are very similar to the absolute value functions: if a is a positive or negative number that is greater than 1, the graph is going to get real tall and real skinny. Whereas if the a is a fraction between 0 and 1, then the graph will become kind of short and wide. And really, you don't have to remember any of that because you can always plot points. Now, the main thing is to figure out where this vertex is. Where does our graph start? And we find that by using negative b over 2a. That'll give us the x-coordinate of the vertex, and it will also tell us where this axis of symmetry is, so that we can go with the mirror image on either side. So when we find one point, we automatically know the other point. And figuring out one of the points is pretty simple because we have an automatic point at 0C. So as we walk through this, it'll be a step-by-step progression, and by the time you're done with it, you should be able to graph a parabola. And it's very important that we take our time and do this stuff right, because this is the majority of what Algebra 2 is working with these quadratic functions and parabolas. Now we're going to start out with graphing this equation right here, y equals 2x squared minus 8x plus 6. It's going to be a step-by-step process, so all we got to do is just follow along with these steps. So first off, step 1 is to identify a, b, and c, or as it says here, find the coefficients. Coefficients are basically the numbers that are in front of your variables, or they could be the constant here. So again, a is always the number that's in front of x squared, so in this case a will be 2. B is always the number in front of the x. We make sure we bring the sign with it, so in this case it'll be negative 8. And in this case, C is always the number that's alone, it's a constant, so here it's going to be 6. Our next step is step 2, where we find the vertex and the axis of symmetry. And again, finding the vertex starts with this right here, x equals negative b over 2a, or opposite b over 2a. So this negative sign is going to be there automatically for us, so we can bring that in. Now we bring in our value of b, which is negative 8, divided by 2a, or in this case 2 times 2. So we want to simplify that out. A negative times a negative will be positive 8 over 4. So now we can simplify that down to 2. So our x-coordinate will be 2. At this time, I'm going to do step 2 and 3 kind of together at the same time. So as you can see, we've got x as our x-coordinate of the vertex, which is 2, and that is denoted by this green line that's running right here. So that is going to be our axis of symmetry, which is also step 3. Now, what we need to do is find a y-coordinate that's going to land somewhere along that line. And we find y the same exact way we've always found y, and that's plug in a value of x. So we're going to plug this value of x right here in place of x here, and that will give us our y-coordinate. So y will equal, and don't forget to put your parentheses in, it'll just help you along the way. So 2 times 2 squared minus 8 times 2 plus 6. So you can go ahead and plug that into your calculator all at once, and that will give us negative 2. So now we can go ahead and plot a point of where this vertex is. It's at 2, -2. So again, we already know the x-coordinate. Now we just come down to the y-coordinate and plot our point right there. So now it's just a matter of finding out this step 4, which is very simple. We have an automatic point at 0c. So basically what that says is we can plug 0 in place of x, and we're going to get c as our answer coming out, so our y-coordinate is going to be 6. So we have a nice coordinate automatically at 0, 6, which should be right here. Now we can go ahead and use that axis of symmetry to our advantage and know that we have an automatic mirror image point over on the other side, right there. Now it's just a matter of following step 5, evaluate one other point and its symmetry point. So that's just pick some number to put in for x and see what you get for y. Now my recommendation is you pick something easy, like in this case 1 would be a nice easy number to plug in because it'll be somewhere between these 2 points here, and you'll get an automatic mirror image over here somewhere. So just go ahead and plug 1 in place of x to see what you get. Now, in doing that, we have y equals 2 times 1 squared minus 8 times 1 plus 6. So we're putting 1 in place of x to see what we get for y. And again, we can just plug that in all into our calculators at once, but I'll do it a little bit slower here. 1 squared is 1 times 2 will be 2 minus 8 plus 6. So 2 minus 8 plus 6 is going to be 0. So we automatically have a point now at 1, 0, which will be right in this area, and we have a mirror image point here. Now all that's left to do is step 6, draw that parabola, which is kind of a nice, slow, smoothing arc up in each direction, and there's your parabola. Here we're going to run through another example, but this time it's going to be a little bit quicker than the last one. And again, you can work this on your own. You can go back to the other one and get a little more step-by-step instruction on it. But again, we're just going to go through the steps on this, identifying first A, B, and C. So A in this case is going to be -1, B is going to be 6, and C is going to be -8. So now we go on to step 2. We can find the x and y coordinates of the vertex. We start out with x by just plugging in -b over 2a. So we'll have the negative is there times 6 over 2 times -1. So that will reduce down to a +3. Now we can find the y coordinate by simply plugging this back into our equation up here. And remember, f of x is the same as y. So we have y equals the negative of 3 squared plus 6 times 3 minus 8. And that winds up giving us a y coordinate of 1. So we have our vertex. It's at 3, 1. So we'll just write that right there. The vertex is at 3, 1. And we can plot that point. That'll be right around in there. Now, remember, that gives us that nice axis of symmetry that we'll put right there. So we have our vertex, we have our axis of symmetry, and now we have an automatic point right here at step 4, 0c. So we get a point at 0, -8. So we can go ahead and plot that point, which would be there, and we get the automatic mirror image, which happens there. Now it's just a matter of picking one more point that we want to plot. So if we just do our little t-chart here, we put 1 in place of x, we go through the math on that, so y would equal the negative of 1 squared plus 6 times 1 minus 8. We wind up getting -3. So we have our point 1, -3 that we can plot right here. And again, we have its mirror image, which would be here. And now we can go ahead and draw our parabola. Obviously, you want to draw it a little smoother than that, but that's kind of the gist of it. The last thing you're going to learn about is how to find the minimum and maximum values. And believe it or not, you're already doing that. If all you do is follow steps 1 and 2 from before, then you can find the minimum and maximum, because all it's really talking about is the y-coordinate of the vertex. So if you pay attention right here, at the vertex, at the y-coordinate of the vertex, the graph opens up, which gives us a minimum value. It's the smallest y-coordinate we can have. And the same thing can be said over here. When the graph opens down, the y-coordinate of the vertex will be the graph maximum. So if we go back to the equation we just got done working with, y equals negative x squared plus 6x minus 8, we can notice right here that a is negative, so we automatically know that we will have a maximum. Now, all we really need to do is figure out what that maximum is. So again, we just follow steps 1 and 2 from before, where we identify a, b, and c. So a will be negative 1, b will be 6, c will be negative 8. And now we can just go ahead, find the x-coordinate, which is negative b over 2a. So in this case, negative 6 over 2 times negative 1. So our x-coordinate will be 3. Now we just plug that in to find our y-coordinate like we did before. So y equals the negative of 3 squared plus 6 times 3 minus 8. So when we do the math on that once again, we come out with y equaling 1. So there is our maximum value. The max is 1. Okay, here's the assignment that you're going to get next time we meet in class. Good luck.